Feel free to enter them into the chat box, and at the conclusion of the webinar, we will review all your questions and provide you with answers and send the responses to the live participants today.
There, I can, was trying to get my video working. Sorry, Aislinn. There we go. Hi, everyone. My name's Nathan Kostrin. As Aislinn said, I'm with the Motor Safety Association of Saskatchewan, and I've been a safety consultant with MSA for going on 7 years now. And prior to that, I spent a little bit of time in my younger years in the oil and gas industry. I spent almost a decade in loss prevention, 3 of those years as a manager. I also spent almost a decade in baseball instruction, which was and still is a hobby and passion of mine. Once I completed my bachelor's degree at the University of Regina, I actually joined the Motor Safety Association and obtained my certification in health, safety, and environmental processes. And yeah, here we are today. So I'm going to pass it back to Aislinn very quickly to introduce herself a little bit more. And I'll be speaking with you folks here shortly as we begin the program.
Perfect. Thanks, Nathan. So as Nathan said, my name is Aislinn Balick. I've been a safety advisor here with S2SA for 4 years. Safety became important to me after I was working actually in an aerospace company as environmental co-op student there. Although I wasn't there to learn about safety, the environmental office was in the health and safety department as well, and that's when it really became clear to me how important safety is. From there, I did return back to school and completed my occupational health and safety program at Red River College, and then shortly after started my career here at S2SA. Here is where I help businesses in Manitoba, again, understand Health and Safety Act and regulations and achieve Safe Work certification. So getting into our webinar, we're going to start off with our agenda. So today what we're going to be covering is what an electric vehicle is and the different types of EVs. So we're kind of be going through electric vehicle, but if we say EVs, that's what we're talking about. We're also going to be talking about the different types of batteries that electric vehicles can have. We're going to go through some of the safety risks of electrical vehicles, as well as some emergency protocols to follow. And then to wrap things up, we're going to review some control measures to minimize those safety risks of EVs. We also want to thank the Manitoba Motor Dealers Association Lead the Charge program for sponsoring today's webinar. They've provided us with 3 grocery gift cards for participants who are engaging within the webinar. So again, feel free to use the chat box and the question box. Again, for more information on the Lead the Charge program, you can scan that little QR code at the corner of the slide, and it'll pop up with more information for you.
So I'm going to turn my webcam off here so you folks can focus more on the slides and less on my ugly mug here. So I'm going to stop my webcam. And as I said, if you have any questions as we go through the webinar, as Aislinn said, please put them in the chat box. But without further ado, let's get started here. So kind of just some basics here out of the gate. I guess in recent years here, we've begun to see a large-scale push now towards the adoption of electric vehicles. And one of the primary drivers of this change is the government's response to climate issues and their goals of meeting vehicle emission reduction targets, which began in the early 1990s. And obviously, we're seeing that full force here now as we head into the future here. As a result, vehicle manufacturers, they've had to adapt and ramp up their efforts to offer consumers alternatives through advanced battery technology and hybrid options that are meant to help meet those targets while satisfying consumer demands for environmentally friendly vehicles. So with these various alternatives and technology, which is constantly evolving and it's going to continue to evolve over time, there's several different terms you're going to want to be familiar with as it relates to electric vehicles. I'm sure many of them you're already familiar with, but this is kind of our soft introduction to the topic. So touching on what is an electric vehicle exactly? Well, in short, an electric vehicle usually refers to any vehicle that is powered in part or in full by a battery that can be directly plugged into the electrical grid for charging. So there's various types of electric vehicles, and EV is a wide umbrella term that can encompass many different subtypes, and some of them you see here. BEV is a battery electric vehicle. They're also referred to as PEVs, or pure electric vehicles, that run exclusively on battery power, and they don't produce any tailpipe emissions. Then we've got the two that you're more familiar with, the HEV hybrid option. It's a vehicle that uses both an electric motor and an internal combustion engine to achieve better efficiency. They're an older form of electric vehicle. They're not considered a true EV. The vehicle's internal combustion engine also charges the battery, as opposed to using an external power source and plugging the vehicle into a charger or electrical socket. Bring in plug-in hybrid electric vehicles, PHEV. These are the more, newer versions of the hybrids. They include a plug for charging its internal batteries, allowing it to run on electricity for longer than a conventional hybrid. These vehicles are newer. Essentially, it is the same as a regular hybrid, with the exception that it has a larger battery pack that can be plugged into the electrical grid for charging. They were designed so that the primary power source is electrical, but when the battery can no longer provide enough power to the internal combustion engine, to the vehicle, the internal combustion engine takes over. And that's the last one, ICE, or ICE, internal combustion engine, and that's the traditional vehicles you're all accustomed to that run on petroleum fuel. So now we've kind of touched on the vehicle types. Let's touch on the battery types, because that is what powers them, and a main reason why we're here to talk about electrical vehicles. And this is one of the main drivers or components of the vehicle. So the two types of high voltage batteries that are predominantly found in production vehicles right now are lithium ion battery vehicles and nickel metal hydride. Lithium ion batteries are made up of carbon and highly reactive lithium, and that lithium ion stores high amounts of energy. It's primarily used in the battery electric vehicles and the plug-in hybrid vehicles due to their high energy density and performance. We also have nickel metal hydride batteries. A lot of vehicles use these as well. They use hydrogen to store energy, or the battery uses hydrogen to store energy, plus nickel and another metal such as titanium to secure the hydrogen ions. So you'll see a mix of these types of vehicles on the road. For the most part, we're seeing a lot more lithium ion vehicles as opposed to nickel metal hydride. They both are, they still have 12 volt batteries, these vehicles. Some of them even have two 12 volt batteries, and they're needed for things like the lights, wipers, the in-car entertainment systems, other smaller electrical features of the vehicle, including some of the safety systems. Something to note is that if that 12 volt battery goes dead, you're actually not going to be able to start the vehicle. Very similar, obviously, to the internal combustion engine vehicles. However, when it comes to jumping them, that is a little bit different. You should never use one of these vehicles to jumpstart another vehicle, as that power spike may actually damage some of the sensitive electronics in the vehicle. So you'd want to refer to your manufacturer's instructions when doing that, and ideally use a jump pack. And I would be remiss not to discuss solid state batteries. This is kind of newer technology within, not new in the sense of the battery technology itself, but in terms of widespread application for electric vehicles. This is what they're trying to move to in the future. Essentially, and again, this is that evolution of the electric vehicle that we're seeing, and we're going to continue to see. It's all about greater performance and safety, and that's where the solid state batteries comes in. It uses solid electrodes and a solid electrolyte instead of the liquid or polymer gel electrolytes that you would find in things like lithium ion batteries. They're believed to have higher energy density. They avoid the use of dangerous or toxic materials that you'll find in the lithium and nickel metal hydride batteries. And they're believed to have a much lower risk of catching fire, as most liquid electrolytes are flammable, like the ones seen in again, nickel and lithium. Whereas with the solid state batteries, the electrolyte is solid and non-flammable. So there's a bunch of positives to that, especially from the safety profile of the battery. One of the main drawbacks and why it's been maybe slow to market is the fact that they're very expensive. And so I'm not sure if we'll see that reflected in the price of new electric vehicles or what have you, but that is one of the main drawbacks, and that's something that they're working through as they bring these to market. So we're going to discuss some of the different hazards. I'm going to focus a little more specifically right out of the gate on the batteries themselves. So when we're looking at batteries, there's the obvious hazard of the chemical hazards, right? High voltage batteries, they contain an alkaline electrolyte, which is typically potassium hydroxide in the nickel metal hydrate or in a gel or liquid form. If the battery is physically damaged or subjected to excessive heat, it can actually leak that electrolyte, which can be caustic and cause skin or eye irritation. So you want to avoid contact with leaked electrolyte as much as possible. And if it occurs, make sure that that washed or that affected area is washed very vigorously. And that's where the importance of having eye wash and emergency showers at your facilities is very important as well. This electrolyte is colorless, it's odorless, so it can't be identified just by looking at it. So don't put your finger in it and taste it or smell it. It's very harmful to your health. If it gets in your eyes, it can blind you. If it gets into your bloodstream, it could potentially poison you. So you can actually dilute or neutralize the electrolyte by diluting boric acid or vinegar. And once it's neutralized, the spill is harmless and can be washed away. So another thing is those electrolytes are very flammable, as I had mentioned earlier, and they can be released in the event of a thermal runaway or physical damage to that battery. So it poses a risk of fire or explosion as well. So there's also the potential for hydrogen gas production. So in the nickel metal hydride batteries, especially during charging, they generate hydrogen gas. So while the production of hydrogen is typically not a major issue, there are rare cases that if the battery is overcharged or damaged, it can actually release hydrogen gas, which is flammable and potentially explosive if it accumulates in an enclosed space. So that's something to be aware of. Toxic fumes. So in the event of a lithium-ion battery fire, toxic fumes and smoke can be released, which both pose health risks to anybody nearby. That's going to be especially true for first responders and our folks in the towing industry that are arriving to these scenes. So make sure that once you've identified that you stay very far away from it, because you don't want to be breathing that in, and let the fire department handle it because they have the appropriate equipment to respond to those types of issues. Thermal runaway, this is a big one, probably something you've seen on TV or in videos. It's a critical safety concern, especially with the lithium ion batteries. And essentially what thermal runaway is, it's a self-sustaining exothermic reaction that can occur if the battery is overcharged or overheated, subjected to physical damage. Those things can initiate that thermal runaway. Now, during thermal runaway, the battery temperature is going to increase rapidly and potentially lead to fires or explosions. It essentially creates a domino effect or a chain reaction. And I'd compare this maybe to if you had a pack of matches and you light one match and then you light the other matches and you see them kind of not simultaneous, almost simultaneously, but they start to each individual match light up very quickly until the whole pack is lit up. That's the same thing for when we're looking at thermal runaway with lithium ion batteries. Because of all of the individual cells of the battery, you're going to see that kind of domino effect happen as all of them begin to catch fire. And Aislyn's got a great video coming up here that's going to show you what a thermal runaway situation potentially looks like. So there's also a variety of other issues. Many of these have been mitigated by other safety management systems within the car itself, or battery management systems. So we have things like overheating. Nickel metal hydride is less prone to overheating compared to lithium ion, but they can still get hot during charging or discharging. So there's potential for that. Manufacturing defects to the battery, such as impurities in electrodes or separators. You might have voltage instabilities that those things can all cause short circuits as well. So, and aging and degradation, like any rechargeable battery or like your phone, for example, batteries have a limited lifespan. Over time, they're going to lose capacity and become less efficient. And older, more heavily used batteries may have reduced performance, and they could be more prone to leakage or overheating and things like that. But as I had mentioned, there's a whole bunch of factors that can kind of mitigate or meant to mitigate some of this stuff. The battery management system that Aislyn's going to speak to a little bit in her piece. Conducting regular inspections when you bring vehicles in, making sure that you're storing batteries properly as well. So storing batteries in a cool, dry place away from direct sunlight and heat. Using the right charger that's specifically designed for the battery type of that battery as well. Preventing physical damage when you're handling them, so no dropping, crushing, puncturing batteries, things like that. There's a wide array of different safety designs within the vehicle to mitigate overcharging and over discharging and things like that. So also regulatory standards are very high for lithium ion batteries. They're subjected to stringent safety standards and regulations. So for the most part, I mean, these are, there's always hazards to be aware of, but they are safe vehicles. You wouldn't see any more incidents necessarily in an electric vehicle than you would in an internal combustion vehicle. They are both subject to obviously different hazards and defects and things like that. So looking at some of the more general safety concerns around electric vehicles, obviously the one that really comes to mind is that you're working with high voltage. High voltage electricity refers to electrical potential large enough to cause injury or damage. The definition for the automotive sector is anything greater than 60 volts direct current or greater than 30 volts alternating current as defined by the United Nations guidelines. So obviously the electric vehicles, a lot of them will operate anywhere from 400 to 800 volts potentially. So we're exceeding that by quite a bit. So the danger is there. Those batteries are high voltage batteries, right? They store energy and they're delivered to that drive motor in the vehicle or returned to a battery pack in a very short time. So accidental contact with live wires or terminals, it can result in electric shock, and that could potentially injure or kill somebody. So very important that that your technicians are trained when operating or working on these vehicles. In an electric vehicle, the high voltage cables are colored orange, as you can see in the picture here, so they're easily identifiable. If these wires have to be disconnected, you must switch off or de-energize the high voltage system. So this is going to help reduce that risk of electric shock potentially from that system. Be careful also when you're lifting these vehicles. A lot of these different connections and lines, high voltage lines, will actually run underneath the vehicle. So if you have to be careful not to damage them, if you happen to be lifting the vehicle with a forklift or anything like that, be careful as not to damage those cables. And obviously, if you are going to be moving them with a material handling device, an inspection afterwards is definitely warranted. It's very essential that you obviously take note of any manufacturer recommendations. These vehicles have different layouts, and it's, no layout seems to be the same from one manufacturer to the other. So very important that your operators or technicians are trained as well on how to work with these vehicles. Something of note too is that the battery and the capacitors store the high voltage. Everything else in the vehicle will carry that voltage, or in terms of electrical components. So to make the vehicle safe, the energy is stored in the high voltage battery, but just because the vehicle is safe, it doesn't discharge the battery. The battery, it just contains the energy, I guess, within the battery itself. So as for those capacitors, it's actually recommended that you let the car kind of run down for 10 minutes or wait 10 minutes before doing any work on it to allow those capacitors to actually fully discharge before working on the vehicle. As I said before, those orange cables, they contain high voltage electricity. You shouldn't work with these cables. In most cases, there's nothing to be concerned about unless you're working directly near them, in which case you want to consult with or an EV certified technician, or if you're not one yourself, and make sure that you're taking the right safety steps there. There's also the potential for arc flash anytime we're working around high voltage. And arc flash is where the electrical power jumps between 2 points and ignites the air around it, which has the potential to create sparks, fire, or cause burns possibly to a person nearby. So as an example, only 25 volts of direct current would be needed to create a welding arc that will weld two sheets of steel together. So just imagine what a 400 to 800 volt battery could potentially do. So again, something to be very aware of. Electromagnetic hazards. So electrical vehicle or high voltage batteries and motors, they have high magnetic potential that can severely injure or kill somebody if the proper precautions are not taken. So any person that has a heart pacemaker, any other electronic medical devices such as an insulin pump, they should not be working on these vehicles since the magnetic effects could be very dangerous, obviously. An additional danger of the very high strength magnets used in these motors is trapping fingers, possibly even losing your fingers. For example, when stripping down or rebuilding the drive motor, strong magnets in the rotor can snap back into the place inside the stator without warning and at great force and speed. Special clamps and pullers should be used to prevent this, but if you've seen a video of this, it's crazy, the actual sheer force. And if you've had a magnet, you can just take any magnet, right? That's powerful enough, hold it up to something like a magnet to a fridge, for example, and it'll just kind of come out of your hand and clamp right to the fridge. Well, imagine this on much heavier parts, and obviously having possibly your finger in there. Want to avoid that at all costs. So that's definitely a big hazard to be aware of. One of the other ones is minimal noise that's given off by these vehicles, right? They're significantly quieter than the internal combustion engine vehicles, especially when they're driven at low speeds. And that's shown that the quiet nature of these vehicles is a major risk factor for collisions. There's also the consideration for techs who may be hard of hearing or working on these vehicles, around these vehicles, as they move them in and out of shops, right? Obviously, working in the industry, there's a lot of technicians out there who are hard of hearing or have lost their hearing from years of working with certain types of equipment. So we have to be cognizant of that, and have good traffic control plans and things like that in place. Actually, over the 5 years between 2013 and 17, there was an estimated 19 fatalities and 991 injuries stemming from collisions involving electric vehicles and pedestrians. And additionally, there was 3 fatalities and 523 injuries involving pedal cyclists with electric vehicles. So as a result of this, we've seen other countries as well as the US now adopt new regulations. Canada has recently adopted them, I believe, as of last year in December, to mandate minimum levels of noise from those hybrid vehicles, or electric vehicles, I should say. So under the new requirements, all of these vehicles will now be required to have sound emitters that produce noise at low speeds. So the automaker can determine what type of sound it is, but the volume and pitch needs to be loud enough that a user would be able to hear them if they're speeding up or slowing down. Storage. So properly storing these, it's potentially hazardous if you store them incorrectly. I'd compare this to kind of storing compressed gas cylinders. So there's a few simple rules when you're storing batteries. Don't mix different types of batteries. They have different types of chemicals and things like that used in them. Some of them do not interact well with one another. So again, very similar to compressed gas cylinders, make sure that we store them only with compatible batteries. So don't stack batteries. They should be isolated on separate benches or shelves. Use insulated boxes or benches or shelves. Only allow access to trained personnel. So keep that those areas of your building secure. Don't allow customers into those areas. Keep the batteries dry. Don't expose them to high temperatures. And use lifting equipment where appropriate with insulation if needed. And finally, recycling and disposal. Improper recycling or disposal of these batteries can lead to environmental contamination due to the toxic metals and chemicals contained inside of them. So you should start by checking with your local regulations. Different regions might have different guidelines for handling these. You can speak with your manufacturers. Many have take-back recycling programs for their batteries. There's also different recycling centers. I don't know if we're that far along yet, especially here in Saskatchewan or Manitoba, where we have dedicated recycling facilities for these. That might be something that we see coming down the pipe. But as of right now, like I said, the best people to go to would be your manufacturer, and also refer to any local regulations or guidelines potentially. So emergency response for electric vehicles. So we need to have emergency response protocols for technicians, especially the technicians who are working on these electric vehicles, to ensure their safety and also the bystanders of other folks that might be in the building. this is kind of a general outline on some things that you should really understand or take into consideration when developing emergency response. So first and foremost, training, right? Ensuring that all of your technicians are trained in electric vehicle safety and emergency response protocols. That should include any specialized training with handling high voltage systems, lithium ion batteries, and electric vehicle components. Ensuring that technicians have access to comprehensive information about the EV they're working on, including the location of the high voltage components, safety precautions, and any model specific procedures. I compare this kind of to like having safety data sheets for hazardous chemicals, right? We want to make sure that we have those things readily available and easily accessible to be referred to by people that work on these vehicles. As I had said before, no two vehicles seem to be the same. And there's different types of designs and batteries located in different areas. So you want to have a very intimate knowledge of what vehicle you're working with before you go toying around inside of it, obviously. So training first and foremost. PPE and equipment, so provide the right PPE to technicians working on vehicles. So that goes for insulated gloves, safety glasses, flame resistant clothing, any specialized tools or equipment you need for EV servicing. Emergency disconnect procedures, and this goes part and parcel with training, not just obviously an emergency response, but the training to certify them as being able to work as being electric vehicle technicians, be able to work on these vehicles. Part and parcel of that training is going to be knowing what the emergency disconnect procedures are for the vehicle that you're working on, and also being able to identify any high voltage components on that vehicle, such as cables, connectors, things like that. So again, training, right? That's going to be a theme probably throughout this webinar today. Also, vehicle extrication. So developing procedures for safely removing or extricating occupants or technicians from an electric vehicle in case of an accident or entrapment. This will also include protocols for deactivating that high voltage system and airbags. So again, making sure that we have a plan around the rescue part of it as well. Having emergency response team and plan. Here in Saskatchewan, as part of a fire safety plan, you're supposed to have people that are essentially trained to carry out your fire safety plans. This would be no different when working on electric vehicles. Designate and train a team of techs or staff members as emergency responders for handling EV-related emergencies. So establishing clear communication protocols for those emergencies and ensuring that everybody understands what that is and how to communicate properly in the event we have an emergency. As I always say, practice makes perfect. So ensure that no different than for a fire safety plan, we would be required to hold a evacuation drill once a year annually. I would recommend doing the same for electric vehicles, and I would probably even practice this one more often than just once a year. We want to make sure that our response is appropriate. And this is obviously new technology that we're working with, new emergency response protocols. So we want to make sure people, again, have an intimate knowledge and familiarity with them. Fire safety, you heard me brought it up here just a moment ago. So making sure that we're trained in our fire safety procedures for our building, including the use of fire extinguishers suitable for lithium ion battery fires, that should be provided. Having said that, you will only be, it's only recommended that you do it for a small fire. If it is to the battery pack and you hear that thermal runaway happening, which is typically a popping and hissing sound, you should just stop what you're doing and call the fire department, evacuate the building immediately for a variety of reasons. Number one, they can get very hot very, very fast. And number two, we talked about kind of the toxic fumes and things that can spew out from these fires, something else to be cognizant of. So small fire, extinguisher, you see it getting out of hand quickly, evacuate the building, call the fire department immediately or 911. First aid, making sure here in Saskatchewan, and I think it's maybe Manitoba as well, we do first aid risk assessments to determine how many people need training at our facilities, the number of persons requiring that training, what qualifications they might need. It's also a good idea to have an AED on site or find out if there's any businesses in the area that have one as a shared resource, and making sure that these things are up to date as well, because we want to make sure that we have people that are trained in first aid that can respond to these incidents. So looking at emergency response for emergency response or first responders, sorry, one of the first things these folks need to do is a scene assessment, and you would do this regardless. And so nothing really changes in that part of things. However, we add kind of another layer. So if there's first responders already on site, fire department, police, we want to quickly identify what type of vehicle it is. If it's an electric vehicle, what type of electric vehicle, any potential electrical hazards in the presence of those high voltage components. Occupant safety, making sure anybody that is in the vehicle or even bystanders are safe, especially if we see that thermal runaway and those toxic fumes start spewing from that fire. We want to make sure people are away from it and safe. Ensuring you have the right PPE when you arrive on scene and you've identified you're working with an EV, making sure we've got the appropriate PPE and specialized tools that we would need to work on high voltage systems in the vehicle or in the tow truck. So it's kind of a three-step process they use for disabling these vehicles for first responders. It's identify, secure, disable. So first of all, identify, look for things like badges, labels, vehicle components to help you identify what type of vehicle it is. Secure the vehicle, so whenever possible, always approach that vehicle from the passenger side, chalk the wheel, set the emergency brake, place it in park, and then disable the vehicle. So ensure that ignition is turned off, disconnect the 12-volt battery, and if the vehicle is equipped with a proximity key, ensure that key is at least 16 feet away from the vehicle. High voltage system awareness. So your folks need to be trained, especially the tow truck operators. They need to be trained and have an idea of what they're dealing with and how to identify high voltage components, cables, connectors, location of battery packs within certain electric vehicles, and use insulated tools and equipment if necessary. There's also an app. It's called the ProAssist Hybrid app. And it was commissioned to actually help first responders and other folks understand the special and different requirements of certain types of electric vehicles. So again, important when you're pulling up on scene to have a good knowledge of the type of vehicle, and that app is actually designed to assist with that. It's called the ProAssist Hybrid app. So I've never used it, haven't had a look at it. Interesting. Like I said, it kind of gives you the lay of the land when working on these vehicles so that you know how to approach them safely. Fire safety, as always, be prepared for potential fires, right? You should have your first responders, but tow truck drivers should be trained in fire suppression techniques, and also the use of fire extinguishers suitable for those lithium-ion batteries. Consider that presence of thermal runaway, obviously, and the potential for reignition, and establish clear evacuation procedures for the safety of yourself, other first responders, and any bystanders as well. When looking at damaged and submerged vehicles, be aware that vehicles that have incurred damage are very susceptible to that fire or thermal runaway, especially if it's directly to the battery itself. Electrical components may also be damaged and could cause electrical shock. So again, be very cognizant of that when on scene. There are systems within the vehicle that kill the power to certain components of the vehicle, but that should never be assumed, and all electrical components should be considered live until that vehicle has been disabled. With submerged vehicles, hybrid electric fuel cell vehicles are designed to be safe in water when they're fully submerged. So that high voltage system is actually isolated from the chassis of the vehicle and is designed to not pose a shock and not energize the surrounding water. Having said that, there's still concerns regarding potential shock if you touch damaged high voltage components and the possibility of fire if water penetrates that battery, especially salt water. So we'll be sending out some additional resources that are specific to the towing industry and also technicians. And Aislinn's going to speak to some of those other resources during kind of towards the end of the webinar today. And transporting electric vehicles. So never assume that all these vehicles should be towed the same way. There's some general rules to follow, and never tow an electric vehicle with the drive wheels on the ground. Towing with the drive wheels on the ground may actually cause an electrical fire. Always tow with the deck or with dollies, and decking is the preferred method of transporting most electric vehicles. So definitely something to be aware of. And again, first and foremost, make sure that your people have the training to whether they're working on these vehicles, responding to these incidents. Training goes a long way. And as I said before, Aislinn's going to provide some good resources for training as well and additional education during her part. And with that, I'm going to turn it over to Aislinn. Thank you very much.
Perfect. Thank you so much, Nathan. That was really informative. So where do we go from here? So now that we know a little bit more about those safety risks of EV vehicles, let's talk about how we can protect workers and then also workers who work with and around those EV vehicles. So when it comes to safety, we always want to start with, assessing the risk. What does it look like, right? So a job task analysis or a hazard assessment is a good place to start because this is going to help us to identify those hazards within each job and help us to select, again, those appropriate safety controlled measures and help us to eliminate and minimize the risk to workers. So there's an example there on your screen. This comes from the Automotive Retailers Association, and we're going to be sending out, I think, some information from them. They have some really good examples and guidelines in their EV guidelines manual. And when we are conducting these job hazard analysis, we want to be considering a few factors. So we're going to be breaking down that job by the duties and tasks. We want to identify and assess the hazards and risks to the workers. So Nathan already mentioned many of the hazards of EV vehicles previously. And we want to determine control measures that we can use, again, to eliminate and reduce the risk of the hazard. With that in mind, we want to make sure that we're involving workers who work with EVs, who they're trained, supervisors and managers, committee members, or if you have worker representative within this job hazard analysis process. Again, if you're going to need any additional support with this, you can contact your safety association. So once we've kind of identified each task, we've assessed it, let's move on to some control measures to reduce the risk. Perfect. So some control measures. So high voltage vehicles actually have a number of safety measures built into them to protect owners, first responders, and vehicle technicians. This includes a battery management system, battery casings, thermal management systems, crash-resistant designs, and emergency disconnects. EV owners and service personnel should follow manufacturer recommended practices and be aware of safety guidelines to take the appropriate precautions to minimize any risk associated with EVs and the batteries. One built-in safety system feature is the interlock system. So once this interlock current is broken, the high voltage system will not function. The airbag system is also connected to this interlock system. So if the airbags do deploy, in theory, the high voltage system should be shut down. But again, as Nathan said, we never want to assume that this has happened. We always want to disconnect the service plug and check and test first to make sure that there isn't any high voltage still remaining. If the interlock system is removable, we want to make sure that we're storing it in a designated area away from the vehicle to prevent any bystanders from activating that high voltage system. So as you'll see in the slide, you'll see some high voltage cables, so colored in orange there. These high voltage cables require greater insulation to prevent the voltage from leaking and to reduce the risk of harm if they're touched. So high voltage components and cables should undergo a visual check for damage, correct routing, and security. During this visual inspection, you want to look for any external damage or broken or torn sheathing and any unusual deformations or discolorations. If the high voltage cables are damaged, they can actually be repaired, so they must be replaced. The manufacturer designs these cables for a specific length, and any changes to this length can cause change in internal resistance and could affect the vehicle's operation as well. So although EVs require a little less maintenance than our conventional vehicles, inspecting them before they come into the shop and doing any work on them is still very important. When they come in, EVs should be a standard practice to be inspecting them. We want to make sure that we're also following the manufacturer's recommended inspection items and scheduled services. Additionally, when working on EVs, we want to make sure that we have warning signage, cones, or barriers. This is essential to make sure that everyone is aware this vehicle contains high voltage. It also helps to ensure that staff who aren't qualified don't come into the work area when qualified staff are working on these high voltage systems. Again, only properly trained personnel with specialized personal protective equipment are to service and dismantle hybrid and electric vehicles. As we kind of talked about earlier, those emergency response plans and the location of emergency equipment must be reviewed with staff. Again, training, training, training. You must ensure that emergency equipment such as your eye wash station, showers, first aid, and fire extinguishers are maintained and readily available. When we are developing those emergency plans, we want to make sure we're going to be consulting the original equipment manufacturer's emergency response guides. There's also another good resource, which is the National Fire Protection Association, and they actually maintain a collection of emergency response guides, I think about 35 of them for alternative fuel manufacturers. Again, we're going to be providing you with these resources at the end of the webinar. If an EV fire does occur, again, we want to make sure we call 911. That thermal runaway could happen, and as you'll see in the video, things can get out of hand very quickly. So it can take approximately 10,000 liters of water applied directly to the battery to actually fully extinguish it and cool down a battery fire. Again, a battery's temperature must be controlled for at least 1 hour after it's cooled down, as there's also a risk that the battery can reignite. And with that being said, we're going to kind of move into a video here, which explains this pretty well. Nathan already mentioned earlier the importance of having fire extinguishers that are suitable for EV batteries. Although this is a requirement for businesses, this is going to be a video on a fire blanket, and it's a really good alternative for EV battery fire suppression. So again, you'll see it's used by firefighters here in the video. The Fire Services of UK said this blanket is very easy to use, doesn't require any water or foam. You don't have to worry about water running off. And again, cleaning up that mess afterwards. It does contain the fire and doesn't create smoke issues, and it is reusable. Again, when we come to reusable, you can use it on, it says up to 30 fires, but again, if you're having more than 30 fires, I think you might have a little bit of a bigger problem. So let's watch a short video on the use of a fire blanket.
So sorry if the video, somebody had commented that the video was a little bit choppy and audio wasn't coming through great, but more than anything, this is for example purposes, and I know you can find some of this stuff online as well, but I'll just turn it back to Aislinn. Sorry if anybody had any video issues there, audio or video.
Great. Thank you, Nathan. So again, it kind of gives us a little bit of a visualization when it comes to how quickly these fires can get out of hand and how important it is to have those emergency procedures in place. So going into a few more control measures now and looking at personal protective equipment. So the use and care of this equipment is very important. So safety goggles, face protection, and flame-resistant clothing can provide a worker in the event of, protection from arc flash and sparks. We always want to make sure we're wearing full-length clothing when we're working on these vehicles and removing all metal items from outside the body. So any rings, jewelry, watches, belts, any pens. In the event of an arc flash, if it's big enough, any metal on the outside of your skin can melt into your skin. With that said, I want to move on to high voltage insulated gloves. So these must be worn when working on vehicle components. And before these gloves are used, they must be visually inspected for damage, cuts, or splits, and then also air tested to ensure that they can hold air. So this leak check is required to confirm that there's no pinholes in the gloves, and always use an air test. Never fill them with water to complete this test. Once the work has been completed, the gloves should be put back into the bag they came in and stored flat. Do not fold them up, as this will put strain on the gloves and could cause damage. It's also recommended that these gloves are tested and certified every 6 months. Lastly, I want to talk about over boots and rubber matting. So when it comes to electricity, it wants to get from the battery to the ground, and the human body can be used to conduct this energy. So the energy cannot reach the ground by insulating the operator's hands and feet and protecting the operator from any fatal shock. Again, 1,000-volt rubber matting on the floor and high voltage over boots can also provide this protection to the worker. Moving on to multimeter or voltage detector. So this is going to be another essential piece of equipment used in vehicle shutdown and the test process. So this device is used to check the absence of voltage and make sure that this is done at a suitable test point. Like those high voltage insulated gloves we just talked about, there are going to be some tests you need to complete every time this device is used to confirm that it works correctly. We also want to make sure we're using high voltage tools, and again, rated at 1,000 volts. When working on these high voltage components, these tools again are essential for protecting staff. And one of the most important pieces in our safety kit is going to be the safety hook, and you'll see it there on the screen. This is going to be used to rescue a person suffering from electrical shock who is still in contact with the source. So it's safely separating them from the source, and this device again could save someone's life while protecting the person that's rescuing them. Never attempt to pull a person away without the correct safety equipment. And this hook should be close to where the people are working on electric and high voltage vehicles and available for immediate use. Again, we want everybody in the business to know where it is and know how to use the hook in case of emergency. With that being said, I want to move into electrical vehicle training. So we want to make sure that anyone who is working on high voltage components has the proper training, equipment, and certifications. So technicians may require additional training beyond the automotive service technician training when working on electric vehicles. Again, we want to consult the vehicle manufacturer to verify the necessary training courses required. Again, like Nathan said, it's like having a safety data sheet. Every EV is a little bit different, so we want to make sure that we are meeting the requirements for each one. Again, we want to make sure we have safe work procedures for working on high voltage electric vehicles. This is a requirement of the safety and health regulations, and it's also a part of Safe Work certification here in Manitoba. When developing those safe work procedures, we want to consult a qualified technician to determine those general steps when we are working on a high voltage vehicle. Additionally, again, we want to consult those OEM manuals, and applicable standards for working on EV vehicles when developing these procedures. Lastly, I want to talk about providing training to all employees. So this is essential because everyone in the workplace at one point or another could be in contact with an electrical vehicle, right? So thinking about people like our lot attendants, service advisors, detailers, and just staff walking through the shop. So all staff should be aware of the hazards of electric vehicles and how to protect themselves as well. So moving into our last piece here, into our resources. So we talked about a few of these today. And again, these are going to be kind of sent out to you in the next few days after the webinar. But as we see more EVs becoming readily available, we expect to see additional safety standards and legislative requirements coming into play. So we talked about the Automotive Retailers Association. So they've developed a safety and health guideline for handling electric vehicles and high voltage batteries. And they also have many online EV friendly training courses, which are pretty good. We have the National Fire Protection Association. And again, that's who maintains a collection of those emergency response guides to reference. And lastly, the original equipment manufacturers, so our OEM manuals and any other applicable standards for working on EV vehicles. We want to be considering those when developing any procedures. So with that being said, I would like to thank the Manitoba Motor Dealers Association's Lead the Charge program for sponsoring this webinar. Again, our 3 lucky viewers will be provided with a grocery gift card. So again, get in that chat box, or if you have any questions, get them in there now, so you'll be eligible to win. Our Lead the Charge program is to help increase and access the availability of electric vehicle charging stations within Manitoba. And for a limited time, funding is available to cover up to 50% of that installation cost. So you'll see some contact information on your slide, as well as you can scan the QR code for more information. So with that being said, that brings us to the end of our webinar. Again, please feel free to reach out to MSA if you're tuning in from Saskatchewan. And if you're coming from Manitoba, please feel free to contact S2SA if you have any further questions. Again, if you submitted any questions in the question box, your association will be contacting you back to answer any of those questions. So we want to thank everybody for attending. We really appreciate it. And with that being said, I'll pass it back to Nathan if he has anything else to add.
Perfect. No, thanks, Aislinn, very much. And thank you, everybody, for being here. We really appreciate your time. Just so that you know, we will be sending out some additional resources after, actually on Monday, we'll be sending those out. So you can expect those to come through in your email at some point. Like Aislinn said, there's a lot of great different education and training and things like that out there, and we'll try and provide as much resources for you. However, like I said, we're providing resources. That's not a substitute to actually go and get training and do things like that. So this is just one component of it. But again, thank you so much for being here. We really appreciate your time. And yeah, hope you have a safe rest of your summer or whatever's left of it. And we'll hopefully be seeing you folks down the road. So thanks again for joining us today. Take care for now.